In this video, we're going to talk about simplifying algebraic expressions involving exponents. Here's a quick rule to help you simplify some of these expressions. Whenever all of the following apply, first, there's an exponent operating on an entire expression, and second, the expression has only one term, or the expression has only one term in the numerator and one term in the denominator. Then what you can do is, in quotes, distribute the exponent to each exponent in the expression, and be sure to include exponents of 1 that aren't typically expressed, as well as be sure to include coefficients. I put the word distribute um, in quotation marks because it's not generally what we mean when we say distribute, but it's kind of what's happening here. So for example, what if we had 5ab squared quantity to the 3? Well, what I'm saying is you can take that 3 and distribute it to the 1 that's operating as an exponent on the 5, to the 1 that's operating as an exponent on the a, and to the 2 that's operating as an exponent on the b. And what you get multiplying is 5 to the 3, a to the 3, b to the 6, which is the same as 125, a to the 3, b to the 6. Now you might be wondering, well, why does that work? And the answer is multiplication is commutative. It doesn't matter if we're figuring out 2 times 3 times 4, or if we're figuring out 2 times 4 times 3, or 3 times 4 times 2. They're all going to equal the same. It doesn't matter what order we multiply them in. So if I'm given 5ab squared quantity to the 3, then what I'm really being given is 5 times a times b quantity to the 3, which is the same as 5 times a times b times 5 times a times b times 5 times a times b. Now, since it doesn't matter what order we multiply these things in the next step I just show us exact same order but getting rid of the brackets. Since it doesn't matter what order we multiply them in, I'll say 5 times 5 times 5, which is right there. Now notice that's the same as 5 to the 3. And then I'll just say a times a times a, which is shown right here, which is the same as a to the 3, which is what I had a minute ago. And then I've got b times b times b times b times b times b, which is b to the 6, which is what I said earlier. And that ultimately, we can't simplify a to the 3 or b to the 6, but we can simplify 5 to the 3 to make it 125. So we can simplify it to that. So what I just showed you there actually does work, and it's because multiplication is commutative. We can multiply in any order. So if now the next slide here, what if we had a fraction inside with only one term in the numerator and one term in the denominator? Well, the same thing would work. We could take that 3 and distribute it to the exponent 1 on the coefficient of 3, to the exponent 1 on the a, to the exponent 2 on the b, and then also to the exponent 1 on the coefficient of 4, and the exponent 3 on exponent 1 on the coefficient of c, and we would get this expression here, which would 3 to the 3 is the same as 27, and 4 to the 3 is the same as 64. And so ultimately what we would get is 27 a to the 3 b to the 6 over 64 c to the 3. Now you might wonder, why does that work? Well, basically, here's a really long slide, but when you have this expression raised to the exponent 3, you're really just putting them all next to each other. And so what you're really doing is, instead of 3ab squared, we'll call it 3 times a times b times b. Instead of 4c, we'll call it 4 times c, and we just have 3 of them next to each other. So our our numerator is just 3 times a times b times 3 times a times b times 3 times a times b, which is what's written here. And our denominator is just 4 times c times 4 times c times 4 times c. Now we see we can just take those 3's and multiply them. We've got, there they are. And we can take these a's and multiply them. And there they are, again, because multiplication is commutative. It doesn't matter what order we do them in. We can take those b times b's, 3 of them, and put them next to each other. And then we can, underneath, say 4 times 4 times 4 is, well, we should have had 4 times 4 times 4. It should be written like that. And c times c times c should have been written as c times c times c. But ultimately what you get underneath is 4 becomes 4 cubed. C, and c becomes c cubed. And up top we wrote it, I showed it properly, 3 to the 3, a to the 3, b to the 6. And so what you end up with is 27 a to the 3 b to the 6 over 64 c cubed. So that idea, these last couple of slides, they were really long. It's not how you have to approach a question. It's just to show you that the simple way of doing things that I described on those first couple slides is the way it can be done. And finally, another rule that we can show you before we get into showing you how to do a few examples quickly. If there's only one term in the numerator and only one term in the denominator, and if you have a negative exponent in the numerator, you can make the exponent positive and put it in the denominator. Or if those same conditions apply and there's a negative exponent in the denominator, make the exponent positive and put it in the numerator. Okay, so why does that work? Well, I'll just show you here. If we had 5a to the negative 2 over 2b cubed, that would be like saying 5 times 1 over a quantity squared divided by 2b cubed. Well, that would be like saying 5 over 1 times 1 over a squared. And this 2b cubed, since we're dividing by 2b cubed, it's like saying we're multiplying by 1 over 2b cubed. And so up top, we would ultimately have a 5, and down below, we'd have a 2a squared b cubed. And so that's what I'm trying to say to you. What you can do to make it a little quicker, since there's only one term up top and one term down below, is keep that 5 up top because its exponent is positive. Keep that 2 down below because its exponent is positive. Keep that b cubed down below because its exponent is positive. And that a to the negative 2 that you see here, that's the negative exponent, put it down below and make its exponent positive. And that's what we have. So it would have been quicker just to do that. And similarly, you could have an exponent that's negative on the bottom. And so what we want to show you is if you had this expression right here, you would keep the 2 in the numerator, the x in the numerator, you'd keep the 7 in the denominator, but because you have that y to the negative 3 in the denominator, make it y to the positive 3 and put it up top. And this should be your final answer. So if you want to see why you can do something like that, I'll show you. This 2x stays up top. And this 7 times y to the negative 3 becomes 7 times 1 over y to the exponent positive 3. So that 2x becomes 2x over 1. That 7 becomes 7 over 1. And this 1 over y to the exponent 3 becomes 1 over y times 1 over y times 1 over y. So what we end up with is 2x over 1. Now this bottom part, this 7 times 1 times 1, that becomes 7. And this 1 times y times y times y becomes y cubed. So what we ultimately get is 2x over 1 times y cubed over 7, which equals 2xy cubed over 7, which is what I said it would equal up here. So you can remember these quick ways of doing things, and they'll help you answer a question. So here's an example of a question right here. This is a pretty complicated one. And let's just kind of go through the steps. First thing we want to do is where we see the third root right here. Instead of that, let's just call it, raise it to the exponent 1/3. So we took that interior part, 27 x to the 6 y to the negative 9. And instead of saying the third root of it with a radical sign, we just made it exponent of 1/3. And then the next thing we did is we took that negative 1/4 and we distribute it to everything that it's touching. So so we got 16 to the negative 1/4. This negative 1/4 multiplied negative 8 and became 2, so we had x to the 2. This negative 1/4 multiplied that negative 12 became 3, so we had y to the 3. Now, what we can do is we can say this 1/3 multiplies into the 27. We get 27 to the 1/3. That 1/3 multiplies the 6, and we get x to the exponent 2. This y to the negative 9, that 1/3 multiplies the negative 9, and we get y to the negative 3. Now this 16 to the negative 1/4, we make it 16 to the positive 1/4 and put it upstairs. And then we still have x squared y cubed down below. Now, we haven't touched this exponent on the outside. That's okay, we'll get to it. We recognize right away that 27 to the 1/3 is the same as 3, and that 16 to the 1/4 is the same as 2. And we still have that x squared, and we still have that y to the -3, and we still have x squared y cubed, and we've got that exponent of -2 here. Now, what you can do, if you have an exponent of -2, make the exponent +2, but just switch the numerators and denominators. So instead of the denominator being x squared y cubed, now the numerator is. And instead of the numerator being 3 times 2 times x squared times y to the -3, now the denominator is. Okay? Now, what we can do in the next step, we see this y to the -3. It's a factor down below. Let's make it a factor of y to the +3 upstairs. And that's all that happened there. We multiplied 3 times 2, and so we have 6x squared. And so what we have up top, we have a factor of x squared, and down below we have a factor of x squared. So we see we can cancel those out. Up top we have y cubed times y cubed, which is y to the 6th. And down below we have that factor of 6, so it's still a factor of 6. And the whole thing is being raised to the exponent of 2. Now we can take that exponent of 2 and distribute it to each of the exponents. So 2 multiplies the 6, and we end up with y to the 12 up top. And then 2 multiplies the 1 on the 6, so we end up with 6 squared down below. And so our final answer is y to the 12 over 36. Now here's another example. Suppose we had the expression shown here. We've got the 5th root of x to the 8. Well, instead of 5th root of x to the 8, let's call it x to the 8 to the exponent 1/5. Underneath, we have the square root of x to the 3. If you just have a radical like that and you don't see any number here indicating which root it is, it's the second root. So instead of saying square root or second root of x to the 3, we can call it x to the 3 to the 1/2. Now we can take that 1/5 and multiply it by the 8, and it becomes 8/5. So we have x to the 8/5. We can take that 1/2, multiply it by the 3, and so it gives us 3/2. So we have x to the 3/2 down below. Now we have a fraction where we're dividing a couple of powers, and the bases are the same. So we can simply subtract those exponents. So we're literally going to figure out what is 8/5 minus 3/2. And if it's not clear, this piece that I just circled there, that's an exponent. Well, 8/5 minus 3/2 is the same as 16/10 minus 15/10, which is the same as 1/10. Now what we can do is take that 4 that's on the outside, distribute it to the 1/10, and we've got 4/10. So our answer is x to the 4/10, but since we can simplify 4/10, we get x to the 2/5.